Okay, we're going to go ahead and take a look at how to add and subtract real numbers. Again, should be review, but we'll go ahead and take a look at it. So first, let's remind ourselves that subtraction technically is just addition. So we talked about this earlier, but once again, for any two real numbers, so I'm just going to call them A and B, and they're elements of the real numbers, so any two real numbers you can think of. If you want to take A minus B, it would be the exact same thing if you just did A plus the opposite of B. So you can just replace that subtraction with addition. You don't have to do that. Um, if you want to use subtraction, that's fine, but we just need to remind ourselves that technically we can just change all subtraction to addition. All right, so some more vocab. Um, in addition, when we're working with addition, you can add 0 to any real number and it doesn't change the number. So any real number plus 0 will equal itself. And because of this, 0 is called the additive identity. So for addition, if you add 0 to any real number, it doesn't change the number, you just get the number back. So A plus 0 is A, and that's for any real number. We mentioned this earlier, but we'll go ahead and mention it again. For any real number, if you take that number plus its opposite, so A plus negative A, if you add those together, you get the additive identity, 0. So A plus negative A would be 0. So for any two real numbers, so 6 plus negative 6 would be 0, negative 1/2 plus 1/2 would be 0. We call those additive inverses, or opposites, although the more formal name would be additive inverse. Okay, so how do you actually add or subtract real numbers? You guys probably can do this just fine, but we'll just quickly go through it. To add or subtract real numbers, A and B, we'll just use 2, and you can extend it to any number of them. So we'll just use A and B. You can just use a number line. You're not going to be required to actually draw out a number line anytime you add or subtract. Again, we're just kind of reviewing how adding or subtracting real numbers would work. So let's say you wanted to add two real numbers A and B. The first number A, we'll just start there on the number line. And then B, if B is positive, we'll just start at A and we'll move B units to the right on the number line. If B is negative, we'll start at A and we'll move B units to the left on the number line. So for example, let's say you have 3 plus 2. That'll be 5, so let's see why. So we start at 3 and we move 2 units to the right because 2 is positive. Move 2 units to the right on the number line and we end up at 5. So 5 is the sum. Let's say you've got negative 1/2 minus 4. Well, that would be the same thing as negative 1/2 plus the opposite of 4, or negative 4. And we know that's going to end up being negative 5.5. So let's see why. We'll start at negative 1/2. So we'll start right here. And since 4 is negative, we'll move 4 units to the left on the number line. So move 1 unit, 2 units, 3 units, 4 units to the left and end up at negative 5.5, or negative 5.5. So that's one way you can think of how to add or subtract real numbers. All right, so let's go ahead and at this time take a look at the distributive property. So let's have A, B, and C all be real numbers. Well, if you have A times the quantity B plus C, it'll just end up being A times B plus A times C. Or if A is on the other side, it doesn't really change anything. So the quantity B plus C times A, it'll just end up being B times A plus C times A. So, which is the same thing, because multiplication is commutative, which we'll talk about. And then if it's B minus C, nothing really changes because remember we can just make this negative plus the opposite. So if you want to write that out yourself and see that we end up with this, give it a try. So just change that to plus a negative and you'll see that we end up with AB minus AC, or BA minus CA. All right, so down here at the bottom I've got a quick proof of just this first one, and then the other ones would be very, very similar if we proved them. We'll just do this first one. So how do we know it's true that A times this quantity is AB plus AC? Well, let's look. If you've got A times the quantity B plus C. It's just multiplication. So we know how to multiply two things together. It'll just be B plus C, and you'll add it to itself A times. So whatever B plus C is, you're just going to keep adding a bunch of those together. And how many times? Well, there's going to be A of those. Whatever A is, that's how many there will be. So it'll be B plus C plus B plus C plus B plus C, and then however many those are, and there'll be exactly A of those. Well, if we rearrange it, we've got B plus B plus B plus B. There's a bunch of B's. So if we just put all the B's together, and then we put all the C's together, so C, 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 we know that there's going to be A of these, and there'll be A of these. And again, since we know how to multiply, if you have B plus B plus B plus B A times, you would get the same number if you just took A times B. And if you had C plus C plus C plus C plus C A times, then when you add those all together, it'd be the same thing as just A times C. So we're really just using the concept of multiplication a couple times to see why this would be true. All right, let's remind ourselves what like or similar terms are. I typically say like terms just because it's quicker. So like terms are any terms whose variables are the same and the variables have the same exponents. So the variables have to match and the exponents on those variables have to match. So some examples, 3x and negative 5x. And that works because they both have the variable x and they're both being raised to the first power. So it's x to the first, x to the first. 2y cubed and negative 3/5 y cubed because they both use y and y, but they both have an exponent of 3. It could be more than one variable, so xy squared and square root of 11 xy squared. They both have an x to the first and they both have a y squared. So those are like terms. And even something as simple as 4 and 15, those are like terms because technically speaking, 4 you could write as 4 times x to the 0, and 15 you could write as 15x to the 0. So they both have an x and they both have the same exponent, 0. Remember, anything to the 0 power is 1. So this is just 4 times 1, which is 4, 15 times 1, which is 15. So those are all examples of like terms. And it always helps to see things that are not like terms. So like 3x and 4y, those are not like terms because x and y aren't the same. A to the first, b to the first. Well, over here we have a to the first, which is good, but we have b squared. That's not the same as b to the first, so those are not like terms. 5x to the first and 5x squared, not the same exponent, so those are not like terms. So these are examples that are not like terms. Okay, let's just do a quick example using some of these concepts. So let's say you're supposed to simplify 4y plus 2 times the quantity 6y minus 5. So using our order of operations, we have to do the parentheses first. Well, inside the parentheses, we have 6y minus 5. Well, those are not like terms, so we cannot subtract those. So 6y minus 5 can't be subtracted. Since 6y and negative 5 are not like terms. All right, so there's nothing to do inside the parentheses, so next we do exponents, but everything just has an exponent of 1. Well, so we don't have to worry about it. So then we multiply and divide from left to right. So we have 4y plus, and now we have to take 2 times 6y minus 5. So we're going to use our distributive property. So our distributive property said you take what's out front times this first one, so times 6y, minus, take what's out front times 5, so 2 times 5. So now we'll do all our multiplication. So it'd be 4y plus 12y minus 10. And now we do our addition and subtraction from left to right. So 4y and 12y, those are like terms because y has an exponent of 1. So if you have 4 and you add 12, that would be 16 of those. And then we have a minus 10, which are not like terms for the same reason 6y and -5 couldn't be subtracted. And so this is as simple as we're going to get.